Hello ladies and gentlemen, welcome to this video on probability, an important topic in mathematics. Are you ready to master the art of calculating chances and making informed decisions? In this video, we will delve into the world of probability, exploring key concepts and formulas that you need to know to succeed in maths, from understanding experimental and theoretical probability to applying the rules of probability. We will cover it all. Whether you are struggling to understand the difference between mutually exclusive and independent events, or need help with solving problem involving conditional probability, this video is here to support you. Let's get started on this probability journey and make sure that you are well prepared for your maths exam. In this video, we will cover theoretical probability, rules of probability, mutually exclusive and independent events, conditional probability, and more. So first, I'm going to explain theoretical probability. The question that I'm going to use is from June 2019. So theoretical probability is expected over the total. I'm going to use this example from June 2019. It is saying a box contains 20 sweets which are identical in shape and size except for color. 8 of the sweets are yellow and 12 are green. So we are supposed to calculate the probability of picking a yellow sweet. We are going to say probability of picking a yellow sweet is equal to expected over total. So the expected is 8 and the total is 20. So we are supposed to write our probability in its lowest terms. So we need to reduce 8 over 20. If we divide both the numerator and denominator by 4, we are going to get our answer is 2 over 5. So it means that the probability of picking yellow sweet is going to be 2 out of 5. For you to understand on theoretical probability, I'm going to use another example from June 2003. So the question is reading, 20 identical balls numbered 31 to 50 are placed in a bag. A ball is picked at random. Write down the probability that it shows an even number. So first we need to find the even numbers that we have from 31 to 50. We have 32. So these are even numbers that we have from 31 to 50. We have 32, 34, 36, 38, 40, 42, 44, 46, 48, 50. So the probability is going to be 10 out of 20 because we are saying expected over total. Expected is 10 over the total of 20. So we are going to write our probability as 10 out of 20. Probability is supposed to be written in its lowest terms. So we are going to write 10 over 20 is half. In the next question, we want to write the probability that it shows a perfect cube. We don't have a perfect cube between 31 and 50, so the probability is going to be 0. From these two examples, I hope you now understand what is theoretical probability. We can move on to other objectives. So in the next objective, I'm going to illustrate on tree diagrams, how to construct tree diagrams. So tree diagrams is frequently examined part of probability, especially in maths paper 1. First, we should know if it is with or without replacement. So let us dive in June 2017, number 22A, and see how the question on completing the tree diagram was examined. So the question was reading, a bag contains 6 green buttons and 3 white buttons, which are identical except for color. 2 buttons are picked at random from the bag, one at a time, without replacement. So our keyword here is this, without replacement. So it means that in the next pick, the denominator is going to change because it is without replacement. So here we are supposed to complete the tree diagram in the answer space by indicating the probability of each event. So what you need to understand is that at each and every branch, the probability is supposed to sum to 1. Here we are given 6/9. So we are going to say 1 minus 6/9 for us to have this 3/9. And here we are given 2/8. So we are supposed to say 1 minus 2/8 in order to get this 6/8. So I'm going to explain here. So let's say in the first pick, the green button was picked. The probability is 6/9. And then the probability of picking the green button again is now 5/8. Why? Because it is without replacement. It means that if in the first pick there were 6 buttons, so in this next pick it is going to be 5/8, and then we are going to still remain with 3 white buttons, but the probability, the denominator is now 8. And if we add 5/8 plus 3/8, we are supposed to get our answer is 1. Right now we are going to see how the question on completing tree diagram was examined in June 2024. So number 14A was saying complete the tree diagram below by inserting the probability not given. So here we were having this 3/5, 1/3, and 2/3. So what you just need to understand is that at each and every branch, we're supposed to have our total is 1. If we say 1 minus 3/5, we get this 2/5. 1 minus 1/3, we get these 2/3. 1 minus 2/3, we get this 1/3. I hope from these examples, you now understand how to complete a tree diagram. Now that you can now complete the tree diagrams, it is very important now to know how to use the tree diagram to answer the following questions. On this objective, we are going to cover this concept either or, neither nor, both, and at least, right? We are going to extract our question from November 2010. In November 2010, the question on probability was on number 26, carrying out 7 marks. So it is saying, in a shooting game, Nyarai is allowed 2 shots. The probability that she hits the target first time is 0.7. If she hits the target first time, the probability that she hits the target second time is 0.6. Otherwise, it is 0.3. You're supposed to complete the tree diagram to represent all this information. So we said at each and every branch, we're supposed to get the total is 1. So if we say 1 minus 0.7, we are going to get 0.3. And then if we say 1 minus 0.6, we are going to get, our answer is 0.4. And then here, this is the statement that we are going to use, which is saying if she hits the target first time, the probability that she hits the target second time is 0.6. Otherwise, if she fails, it is going to be 0.3. And then we say probability at each branch, it is supposed to sum to 1. So 1 minus 0.3, we are going to get 0.7. So by doing this, you get all the 3 marks in part A. And then we now want to use the probability tree diagram to answer part B. It is saying calculate the probability that she hits the target twice. So we are just going to use our probability tree diagram. We follow where she is hitting twice. here she has hit the target, and also in the second shot she has hit the target. So we are going to say probability that she hits the target twice is 0.7 times 0.6, because if it is twice or both, we multiply the probabilities. If we say 0.7 times 0.6, we are going to get our answer is 0.42. So that is the probability that she's going to hit the target twice. And then on part 2, we want to calculate the probability that she hits the target once. So what happens is here we are forced to make a choice. Either she's going to hit the target in the first shot and fails in the second, or she's going to fail in the first shot and then hit the target in the second shot. So we need to follow that on our probability tree diagram. So right now we want to use our probability tree diagram to find the probability that she's going to hit in the first shot, that is 0.7, and fails in the second shot, that is 0.4, or she fails in the first shot, which is 0.3, and then she hit in the second shot, which is 0.3. So 0.7 times 0.4, we get 0.28, and then 0.3 times 0.3, we are going to get 0.09. So here we are having 0.09, and if the probability is either or, we add our probabilities. So we are going to add here, so that we have 0.09 plus 0.28. Our answer is going to be 0.37. I hope you now understand how to use the tree diagram. I'm going to look for another example. Next example, we are going to use November 2023. So first part of the question was of completing the tree diagram. So we just say 1 minus 0.6 to get 0.4, 1 minus 0.8 to get 0.2, 1 minus 0.5 to get 0.5. And then on part B, it is saying use the tree diagram to find the probability that he scores in both halves. So what we need to do is we are going to check on our probability diagram where we are having shooting and shooting again. So it's scoring and scoring again. So scoring in the first half is 0.6, scoring in the second half is 0.8. So we are going to say 0.6 times 0.8 to get our probability is 0.48. And then on part 2, we are supposed to find the probability that he scores only once. This question is almost similar to November 2010, which we have done before. So the probability that he's going to score only once, either he scores in the first half and he doesn't score in the second half, or he's not going to score in the first half and then score in the second half. So we are supposed to use our probability tree diagram to find these probabilities, and we add. So scoring in the first half is 0.6 times 0.2, and then failing to score in the first half is 0.4, and then scoring in the second half is 0.5. So we say 0.6 times 0.2 plus 0.4 times 0.5, so that we get our answer is 0.32. So I hope you now understand that if the probability is either or, you add the probabilities, and also if it is both, and you multiply the probabilities. And also you know how to draw a tree diagram when it is with or without replacement. When it is with replacement, the denominator is not going to change, but if it is without replacement, it is going to change. So I'm going to look for an example where we are going to have at least. So we'll extract our question from June 2017. So it is saying find the probability of picking at least one white button. So you should understand that when it is at least, it means greater than or equal to 1. When they are saying at least one white button, it means greater than or equal to 1 button. So we have 3 options here. Either you first pick green and then white, or you first pick white and then green, or you are going to pick white in both events. So we now need to add our probabilities. Green white, it is 6/9 times 3/8. White green, it is 3/9 times 6/8. And then white white, it is 3/9 times 2/8. And then after that we add the probabilities in order to get our probability is 7/12. And then the next objective that we want to cover is that one of neither nor. I'm going to use a question from November 2015, Maths paper 1. So it was on number 16. It is saying the probability that Sihle will bring a calculator is 5/6, while is that for Yemrai is 3/5. Giving the answer as a fraction in its simplest form, find the probability that Sihle will not bring a calculator for the lesson. So we are given that the probability that she's going to bring is 5/6. So the probability that she's not going to bring, we say 1 minus 5/6 and get our answer is 1/6. And then probability that only one of them will bring a calculator for the lesson. It is either Sihle will bring and Yemu will not bring, or Yemu is going to bring while least Sihle is not going to bring. So we need to substitute the correct probability. Probability that Sihle will bring, it is 5/6. In that of Yemrai not bringing, we say 1 minus 3/5 to get this 2/5. Or it is going to be Yemu who is going to bring, that is 3/5, while least Sihle not bringing is going to be 1/6. And then after that we add our probabilities since it is either or, so that our final answer is going to be 13/30. So let us now move on to objective number 8. I'm going to first explain what is mutually exclusive events. These are events that do not occur at the same time. For example, when a coin is tossed, then the result is either head or tail, but we cannot get both results. Such events are also called disjoint events since they do not happen simultaneously. Mutually exclusive events are experimental. When we are saying experimental probability, it is the one that is found by conducting multiple trials of an event, such as rolling a die, spinning a spinner, tossing a coin. It is important to know if it is biased or unbiased. So first we are going to work out June 2016. It was a question on coin tossing. So the question is reading, 2 unbiased coins, coin 1 and coin 2, are tossed and the outcomes recorded in table. Complete the outcome table given where H is head and T is tail. So here we are going to have head, head, or we have tail, head, or here we are going to have head, tail. So using the table or otherwise, find the probability of getting 2 heads. So here we are having 4 outcomes. So probability of 2 heads, it is going to be this HH, which is 1/4. So we are going to write our probability is 1/4. And then different outcomes. That is where we are having this tail head and head tail. So it is 2 out of 4, which is equal to half. And then at least one tail, we said at least it means greater than or equal to 1. So we are going to have this tail head, head tail, and tail tail, which means that the probability of getting at least one tail is going to be 3 over 4. So this is how we answer a question on coin tossing. Lastly, today we want to look at a question on dice throwing. We will extract our question from June 2005. So the question is saying 2 6-sided unbiased dice are thrown at the same time. Giving the answer is a fraction in its lowest terms. Find the probability that the product of two numbers shown on the dice is going to be a perfect cube. So what we need to do is we need to draw an outcome table. This is our die 1 and our dice 2. So if we throw them, we need to have the possible outcome as a product, so that if we say 1 times 1, we get 1, 2 times 1, 2, 3 times 1, 3. And then on this row, it is 1 times 2, 2 times 2, 3 times 2, 4 times 2. On this row, 1 times 3, 2 times 3, 3 times 3, 4 times 3, 5 times 3. We go with that pattern till we are done with all the rows. And then after that, we need to find where we are having perfect cubes. The perfect cubes that we are having, we have this one. 1 is a perfect cube. 8 is a perfect cube. And also this 8 is a perfect cube. So we are having 3 out of 36, because these are, if we add 6 times 6, we are going to get a total of 36 outcomes. So it is 3 over 36, and we reduce it to its lowest terms, so that it is going to be 1 over 12. So this marks the end of our tutorial today on probabilities that are examined in Maths Paper 1. Let us meet again on probabilities that are examined in Maths Paper 2, but these are going to be a short video, because the way probability is examined in Maths Paper 2 is not that difficult as the one that is examined in Maths Paper 1. Thank you so much, guys, for following me on this channel. Please don't forget to subscribe, like, and share my videos. I love you all. This is Eve signing out.